start the recording. All right, so station setup and equipment. The most important item is okay, they're going to say right now the most important item is a transceiver, but later on they're going to tell you that your bang for your buck comes from your antenna. If you want to you're all right. Okay, so the most important item is your radio transceiver. A power supply is probably the next most important. I think I mentioned once before that in the old days, everything just plugged right into the wall. But people wanted to be portable because a lot of times you're operating in areas that, are hit by, things like in the Carolinas and East Tennessee there. And by now they've got something going, I'm sure. I think Elon has put some stuff out there. But for a long time, that was really, there was no communications in and out there except for radios. So you got to be able to operate without having an outlet to plug into. So the radios now all run on, 13.8 volts, which is what your alternator puts out on your car. So the power supplies that you buy to run the radio at your house is a 13.8 volt power supply. If you are lucky enough to have access to a power supply that's variable, most of us just buy the fixed 13.8 volt power supply that has a voltmeter on it. And I'm still not sure why that is, because you can't change it. But it's like at work, I've got power supplies all over the place that are variable. So just be sure that you put them in the range where it would work with, best would be 13.8. But like my Xiegu can run from 10 volts up to about 16 volts. And it runs with no problems in that range. A computer is needed for digital modes. So if you plan to run FT8 or if you have a handicap or a disability and you're going to be using anything digital, you're probably going to need a computer because you're going to be doing stuff on a keyboard. Microphones, speakers, cables, and other accessories are necessary. And of course, the microphone and speaker is usually part of your radio. Now, the internal speakers on some radios are really, really poor. So you might, a standalone speaker to plug into your radio is usually $40-50. So for some radios, and it doesn't take much research to find out which ones have poor speakers and put out poor sound, so you know if you're going to need to get a speaker or not. Equipment interconnections and grounding are very important, and an antenna is required. And later on, they're going to tell you when you ask about this noise or getting out farther, they're going to tell you concentrate on the antenna. So even though they say the radio transceiver is the most important part, at some point you're going to have to pay attention to the antenna to get what you want. So like my dipole antenna radiates a donut out. It's running east and west, so it radiates this donut of power out north and south. So I started looking into building a wire vertical antenna because a wire vertical antenna takeoff angle is roughly 7 degrees. So instead of, and it's omnidirectional. So different antennas give you different results, basically is what I'm saying. And I think I spent $80 on the 20-foot carbon fiber telescoping mast, and then I spent another $100 on the 33-foot fiberglass mast. But you could use those for anything. But as far as building the antenna for the wire, just wire and a little unbox that I built, and between the wire and the box, I've probably got $25 into each antenna that I've built. That's not counting the mast. The mast was, had to buy that. But you can just throw a wire up into it, or, throw a line up into a tree and pull the wire up into a tree and do the same thing, which is what you would do for portable. But anyway, your antenna is required. A radio transceiver can draw a lot of current when transmitting. So a 7300 draws approximately 18 to 20 amps if you're running 100 watts. So you do have to have a fairly heavy power supply. Some of these power supplies, and I'll use the name brand Pyramid that says that it's 10 amps or 12 amps or 15 amps, something like that, would not work for a 7300. You'd have, without dialing your output power down. You'd probably dial your output power down to 50, 60 watts, and that would be an okay power supply. But short, heavy wires should be used to minimize voltage drop. So based on the amount of current that you're, back to the fact that most of us have some electrical background, based on the amount of current that your radio is going to be drawing, your power cables to the radio, between the radio and the power supply, should be a certain gauge, right? That minimizes voltage drop and also ensures that you're not going to burn up the wire. Yes, Michelle? Okay, where were we here? Too much voltage drop can cause a transceiver to malfunction. It's going to have to be a pretty serious voltage drop before it dropped down to where it would cut off. But there are certain functions that might, and you won't get, if you're supposed to be running at 13.8 volts and you've got enough voltage drop over that wire, keep it short, like they say, as short as you can make it to be able to get to it. But the longer the wire, the more voltage drop there is over it. And if you drop down enough, then it would start cutting off. Or if it drops down enough, your power would start to drop. You wouldn't transmit the whole 100 watts. Low voltage can cause spurious sidebands as well. And spurious sidebands, you remember we looked at the spectrum where we showed you where the center frequency was in these lobes that are the upper and lower sideband, right? Having power too low can sometimes cause you to generate other sidebands that are not wanted. Power supply requirements. A typical transceiver requires a 13.8 volt DC power supply, either a plug-in power supply that you would use at your home or a battery that you would plug into for portable use. The lithium iron phosphate, the LiFePO4 batteries, some batteries have a drop-off that's gradual. And you'll reach a point where the radio just won't work anymore. The LiFePO4 batteries are flatter. The bad part of that is there's no warning. It reaches a certain point where it just can't function anymore and it's gone. But you maintain a more even operating condition for a longer time. Most transceivers are less than 50% efficient. A 50-watt transceiver will require at least a 100-watt power supply. And there's the math for that. Why are short, heavy gauge wires used for the transceiver's DC power connection? Alpha, to minimize voltage drop when transmitting. Which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? Delta, 13.8 at 12 amps. Very good. Did you do the math or? Very smart. Yes, ma'am. Okay, station setup. Um, a computer is used for digital modes operations such as FT8. And there's more than one software suite that'll do this. Well, maybe not FT8, but WSJTX and FT8 are actually designed by the same guy, one of the same guys. The T in there is, I think it's Thomas. But anyway, provides received audio, transmit audio, and transmitter keying signals. So you've got your radio hooked up to your computer, and your computer decides when to key the radio and when to unkey it. It manages all the outgoing communication and the incoming communication. And for like FT8, FT8 is one of those that where you have a very, very low signal to noise ratio. It can pick the transmission out of noise that you would never be able to hear with your ears. But it's all encoded, and you have to have the software to be able to encode and encode to send out and decode what you receive. Let's see, transceiver audio in out connections to computer audio out in. So, and every radio is a little bit different. So you're going to have to look for the specific instructions to connect your radio to your computer to get this to work. Your computer will have to have a sound card. Most of them do. I mean, this computer here was $250 and it's got a sound card in it. A poor one, but it's got one. Some transceivers can use USB cables for audio and control, which was a consideration when I bought this computer, because I've got 2 USBs, one HDMI and one USB-C. So, and actually, this one right here that goes to the speaker, that's providing the mic input via the USB-C. So, some transceivers can use USB cables for audio and control. Older transceivers use audio cables. Okay. Older, let's see, transceivers speaker out to line in, microphone in to speaker out. So, and there you see station setup, computer. So you got your antenna that goes into one point on the card, and everything else gets connected via the computer audio in and out or through USB. What signals are used in a computer radio interface for digital mode operation? Charlie, receive audio, and transmit keying. Very good. How are transceiver audio input and output connected in a station configured to operate using FT8? Let's see here. How are transceiver audio input and output connected in a station configured to operate using FT8? Let's see, to a computer running a terminal program and connected to a terminal mode controller unit, to the audio output, input and output of a computer. Okay. Anybody? Okay. Bravo. Remember, it had, yeah. And WSJTX is the giveaway there because that's the software for FT8. Which of the following connections is made between a computer and a transceiver to use computer software when operating digital modes? Which following connections is made between a computer and transceiver to use computer software when operating digital modes? So, okay, I did go over that pretty quick. What's that? Yeah. Charlie, computer line in to transceiver speaker connector. Okay. I'm glad you understood that because I got lost on it. Okay, station setup cables, audio, microphone, and power supply cables can pick up stray RF. Stray RF can cause distorted audio. RF can also cause radio and accessories to malfunction. One cure is to install a ferrite choke. And wouldn't you know it, there's not a thing up here that I have that has a choke on it. You know the little things on some of the cables, and they're usually on your computer power cables. I can't believe there's not one on this one. But they have the little magnetic clip-on. Sometimes they're clip-on, sometimes they're built into it. Well, that's a choke. One cure is to install a ferrite choke on the shield of a microphone cable to choke off the RF currents. Ferrite chokes should also be used on USB cables. And none of my cables up here have a choke on them. But what's that? Oh, okay. Yeah, a lot of items have them now, just, comes from the manufacturer that way. Kind of odd that internet radio. Okay, so there's an example of a few different chokes right there. You will see some of them are just like a clamshell that you can snap on. You get those from Amazon and other places. That's what those are. This one here is shown with a coax wrapped through it 3 times. 1, 2, 3, yeah. 3 times through the middle of that one there, so it provides more effect. Another way you can do a choke if you have nothing, depends on the cable you're using too, because any of the coax that you use has a bend radius, so you don't want to violate that bend radius. But like RG58, you can make 8 or 9 coils about 7 inches around, 7 inches diameter, out of your RG58, and then put a couple zip ties on it to hold it in place, and that'll make a choke. So if you don't have one of the Amazon special clamp-on chokes there, you can do it. You can homebrew it. Which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable? Delta, ferrite choke, after we just beat that horse to death, right? Okay, station setup, grounding. Good grounding can help avoid interference problems. All equipment should be connected to a single point ground, just like we discussed earlier. A copper plate or pipe is common. So remember I said I've got a copper plate on both sides of my window pass-through. And in addition to that, you can have just a copper pipe. I won't need one for mine. But you can just do a copper pipe with a couple of brackets to hold it to the wall and run everything to that copper pipe, and then run the copper pipe out. Or run the line from the copper pipe out to your grounding rod. Use short, heavy, flat copper strap or braid. And everybody remembers what I said about braid, right? Braid indoors, flat strap outside. Flat solid strap. And there's an example of both. I haven't found a source for the flat strap yet. The braid, you can get the braid on Amazon, fairly inexpensive. You'd probably want copper rather, I don't know, that might be tinned copper. But yeah, steel's not a great option. Which of the following conductors is preferred for bonding at RF? Delta, flat copper strap. Takeaways, power supplies, heavy gauge wire from your power supply to your radio as short as possible to prevent too much voltage drop. A 50-watt transceiver requires a 100-watt power supply or more. Digital modes requires receive audio, transmit audio, and keying. Transceiver out to the computer input, transceiver in from the computer output. Computer line in to transceiver speaker connection. Noise, use ferrite beads on cables to prevent distorted audio, and in the event that you don't know what size ferrite you need, Amazon will send you 100 of them of all different sizes, and you'll only use one size. So another good reason to be in a club, somebody could probably tell you what size you need, or you just research and find out the diameter of your cable, and then get the right diameter clamp on ferrite. Grounding, all equipment connected to a single point ground, flat copper strap, large surface area. That's the whole purpose of the flat copper strap. You have a large surface area and is preferred for bonding. Any questions?